Hi, my name is Annalise McCullough-Grimaud, and I am currently a final PhD student based at the Music and Science Lab at Durham University, together with my supervisor, Professor Thomas Arola. Today, we are presenting our research on how to explore a large cue emotion space in music, a comparison of two approaches for emotions expressed by music. First, we will outline the research background and aims. We will then look at two experiments which vary in methodology. Experiment 1 is an analysis by synthesis experiment, while Experiment 2 follows a systematic manipulation approach. We will then look at the findings of both experiments together and draw comparisons between the two, highlighting discrepancies. Finally, we will outline implications of the findings and present our conclusions. This research focuses on the role of musical cues and their interactions in the conveying of different emotions through real music. Previous research tended to focus on either one musical cue or investigated 2 to 3 cues simultaneously, each with a limited number of levels. Only 2 studies have tried to explore a bigger cue space with multiple levels and their interactions. Different methodologies have also been used to explore musical cues in relation to perceived emotion. The most prominent methodology is the systematic manipulation approach, where similar musical excerpts are created by slightly varying cue levels and then evaluated by participants in terms of emotion. This approach allows for predetermined changes in musical cues to be investigated. However, the number of cues and combinations investigated simultaneously is limited, as a design with a large number of cue combinations becomes unfeasible. An alternative method is an analysis by synthesis approach, where participants are in charge of changing a selection of musical cues in real time to express different emotions through music. This allows for a large parameter space to be explored at the same time, as cue levels and combinations do not need to be predefined and rendered. These approaches provide different levels of accuracy and economy for identifying appropriate cue-emotion combinations in a large possible space. However, do these approaches provide converging evidence about the cues? This brings us to our research questions. How do the musical cues and their interactions contribute to the expression of different emotions in music? And to what extent do the results from the 2 experiments converge? 7 cues are investigated in this study. We have tempo, pitch, dynamics, brightness, articulation, mode, and instrumentation, in relation to 7 emotional expressions, which have been reported as being expressed in music: sadness, joy, calmness, anger, fear, power, and surprise. Is Experiment 1, which is the analysis by synthesis approach. Participants actively engage with a computer interface called Emote Control, which allows users to alter musical pieces via instrumentation, tempo, pitch, dynamics, brightness, mode, and articulation. As the interface is aimed at the general population, there is no need for prior musical skills. For this reason, certain terms that are music-specific, such as mode and articulation, were renamed into more general terms. As you can see on the slide, mode is referred to as change pitch alphabet, with alphabet 1 being major and alphabet 2 being minor. Playing method refers to articulation, where smooth indicates legato and detached indicates staccato. Cue changes can be instantly heard in real time. 7 tonal instrumental musical pieces were utilized as material. These pieces were derived from a musical stimulus set specifically composed for the interface, and also previously validated via an online experiment. This is one of the excerpts, which conveys joy. Participants were presented with the Emote Control interface and instructed to use the 7 cues available to change the music given to convey one of the 7 emotions designated. Participants did 21 out of a possible 49 trials to minimize fatigue. A short demonstration of how emote control works will now follow. Experiment 2 used a factorial design to systematically manipulate and render variations of the same musical stimuli used in Experiment 1, with different cue levels and combinations. Most cues had 3 levels, while articulation and mode had 2. The full factorial design created quite a large design matrix, which would not be feasible, as it would have had 972 iterations per musical piece. Therefore, we calculated the number of trials needed to provide an optimal geometrical design where every main effect and first-order interactions would be balanced, which gave us 36 trials to work with. The saving of combinations does not allow to test every possible interaction, but makes a comparison of main effects balanced. Each of the 7 musical pieces had 36 variations, which totaled to 252 total iterations. Participants listened to a subset of the stimuli set to minimize fatigue and rated on 7 separate 5-point Likert scales how much of each of the emotions they thought the music was conveying. We had 42 participants for the first experiment, with 8 of them being musicians and 34 being non-musicians. 162 participants took part in experiment 2, with 74 being musicians and the rest being non-musicians. The mean age of participants was similar across the 2 experiments. It is worth noting that the first experiment had to be done in person, and as this experiment was carried out last year in Malta during summer, all the safety regulations in place because of COVID were taken. Experiment 2 was an online-based experiment. This table shows a high-level overview of cue levels used to shape the different emotions in both experiments. For each of the emotions, the cue levels of Experiment 1 are denoted first, followed by the Experiment 2 levels. A minus sign indicates a low level, a plus sign indicates a high level, and a tilde sign indicates a medium level. Cue levels all had a significant effect except for the ones in square brackets. Non-significant cue levels were mostly for dynamics and brightness cues in Experiment 2, which are highlighted in brown. This might indicate that participants did not distinguish between minor changes between the dynamics cue levels in the online experiment. Overall, the cues operated similarly across the 2 experiments, as can be seen in green. For example, a slow tempo, low pitch, low brightness level, legato articulation, and minor mode were used for sadness across both experiments. The cues in red represent the cue emotion discrepancies where both cues are statistically significant and different. For example, instrumentation for the sadness emotion, where in Experiment 1, participants specifically chose a woodwinds instrumentation, while in Experiment 2, participants specifically chose a strings instrumentation. The discrepancies between the continuous cues, which were statistically different, are a matter of nuance, as they were not extreme opposites, but rather a low cue level preferred, for example, in one experiment against a moderate level in the other. Overall, the cue emotion profiles in Experiment 1 scored higher than the cue combinations used in Experiment 2, except for fear, which had the same value in both experiments, and joy. This indicates that overall, the cue combinations chosen by participants in the analysis by synthesis experiment worked better to convey the intended emotions than the fixed cue combinations used in the systematic manipulation design. Mean pseudo R-squared values were computed to show the impact of each cue across all emotions for Experiment 1 and 2 individually. Overall, mode had the highest impact on shaping the different emotion profiles in both experiments. In experiment 1, mode was followed by tempo and instrumentation as most impactful cues, while in experiment 2, articulation and tempo scored second and third most impactful cues. In summary, a similar cue pattern and significance was seen in the two approaches, except for dynamics and brightness cues, which mostly were non-significant in experiment 2. A potential explanation is that it might be more difficult to hear subtle differences in dynamics and brightness in an online study, where the experiment environment cannot be fully controlled. Therefore, perhaps a different methodology that allows more control over the dynamics and brightness cues and research environment might be better suited when investigating these cues. Mode was the most impactful cue across emotions from our cues that we investigated, and analysis by synthesis had a better fit with models than the systematic manipulation approach. Both approaches have pros and cons. The analysis by synthesis approach allows for participants' engagement and direct user experience, where participants can show us how they would change the music to express the intended emotions. This approach allows for a substantially large cue space to be explored in a short time, which would not be possible with a systematic manipulation design, where all combinations would have to be rendered and listened to by participants. A con to giving the participants free rein of the cue space is the possibility that certain cue levels and combinations might not be explored. Another possible limitation is that the current interface uses commercial software and perhaps makes it less accessible to people. One of the pros of systematic manipulation is that the researcher has more control over the cue levels investigated, as they are predetermined. Furthermore, these types of experiments can easily be carried out online, making them readily accessible and available to a larger population. The con of this approach is that it is quite tedious, both for researcher and especially for the participants, to go through a large number of stimuli, and it takes more time. In conclusion, this study has provided two sets of data investigating the same 7 musical cues in relation to 7 emotions. Although both approaches get you to a similar place, the results in this study suggest that the analysis by synthesis approach might offer a promising way forward in uncovering how the cue emotion space operates in real music. Future studies should move away from systematic manipulation approaches and focus more on alternative ways that allow for a better exploration of the large parameter space more efficiently, and expand the cue emotion space to include other cues such as harmony, sound space, and other aspects of timbre, to name a few. Such other interactive paradigms include the self-pacing paradigm, the Markov chain Monte Carlo with people randomized algorithm, and the Gibbs sampling with people. Thank you for your attention, and we look forward to your questions.